Welcome back with another video on this channel. I am Zahin Nazir and we are doing Advent of Cyber 2024. So this is my 7th video on this series. So in today's video we will gonna go with the task 13, AWS log analysis. Day 7. Oh no, I am speaking in Cloud Trail. I think this particular room is or the task is created by Taylor Ramsby, and he also put a nice poem here as well. So the story is a SOC mass approach, so did the need to provide those with something to read. Care for wares tried, they made it their mission. A gift for all wares, a SOC mass tradition. Although they had some, they still needed more. To pick up some books, they would head to the store. The town's favorite books would no doubt make them jolly. They ticked off the list as they filled up the trolley. With the last book ticked off, the shopping was done. When asked for their card, the wearer handed them one. "I am sorry," he said as the shop clerk reclined or declined. "I can't sell you these books as your card has declined." The wearer put them back as they walked in confusion. How could this be an attack and intrusion? And when they logged on, the wearer got a scare to find the donations. They just were not there. Awesome, man, awesome. Whoever created this is awesome. The Princess and the Peacock. Awesome. Payment declined. Okay, so these are all the books related to the tech, and the payment is declined. And there is a very nice room created by one and only Taylor Ramsby. Check this room if you haven't checked it already. It is about AWS, right? Yeah, okay. Monitoring in an AWS environment. Carrier's infrastructure runs in cloud, so they chose AWS as their cloud service provider, CPS. Instead of their workloads running on physical machine on premises, they run on virtualized instance in the cloud. These instances are in AWS called EC2 instances, Amazon Elastic Cloud, Compute Cloud. A few members of the Ware Valley SOC are not used to log analysis on the cloud, and with a change of environment comes a change of tools, and the services needed to perform their duties. Their duties this time are to help care for Ware, figure out what has happened to the charity's fund. To do so, they will need to learn about an AWS service called CloudWatch. Okay, sure. CloudWatch. AWS CloudWatch is a monitoring and observability platform that gives us greater insights into our AWS environment by monitoring application at multiple levels. CloudWatch provides functionalities such as monitoring of system and application matrices and the configuration of alarms on those matrices for the purpose of today's investigation. Okay. So we want to focus specifically on CloudWatch logs. Running an application in a cloud environment can mean leveraging lots of different services, such as a service running the application, a service running functions triggered by the application, a service running the application backend, etc. This translates to logs being generated by lots of different sources. CloudWatch log make it easier for user to access, monitor, and store the logs from all these various sources. Awesome. A CloudWatch agent must be installed on the appropriate instance for application and system matrices to be captured. Okay. A key feature of the CloudWatch logs that will help the Ware Valley SOC squad us make sense of what happened in their environment is the ability to query application logs using filter patterns. Here are some CloudWatch terms you should know before going further. Okay, log events. A log event is a single log entry recording an application event. This will be timestamps and packaged with log messages and metadata. Log streams. Log streams are a collection of log events from a single source. Okay. Log groups are a collection of log streams. Log streams are collected into a log group when logically it makes sense. For example, if the same service is running across multiple hosts. Okay. So if same service is running across multiple VMs, that mean a log stream will be captured inside a log group. Did this make sense? So the log stream could be generated from multiple sources, but what the log stream generated from one single source is called log stream itself, and one log stream could have multiple events. Okay, clear. CloudTrail. CloudWatch can track infrastructure and application performance, but what if you wanted to monitor actions in your AWS environment? These would be tracked using another service called AWS CloudTrail. Actions can be those taken by a user, a role granted to a user giving them certain permissions, or an AWS service, or recorded as event in AWS CloudTrail. Essentially, any action the user takes via management console or AWS CLI or service will be captured and stored. Some features of the CloudTrail includes always on, JSON formatted, event history, trails, deliverables. Okay, always on. CloudTrail is enabled by default for all users. Awesome. JSON formatted. All event types captured by the CloudTrail will be in the CloudTrail JSON format. I mean JSON format, not the CloudTrail. Or the CloudTrail JSON is different than the actual JSON. Event history. When users across CloudTrail, they will see an option, event history. Event history is a record of the actions that have taken place in the last 90 days. These records are curable and can be filtered on attributes such as resource type. Trails. The above mentioned event history can be thought of as the default trail, including out of the box. However, users can define custom trails to capture specific actions, which is useful if you have bespoke monitoring scenarios you want to capture and store beyond the 90-day event history retention period. Okay, so this is what we have trail. Okay, deliverables. As mentioned, CloudWatch can be used as a single access point for logs generated from various sources. CloudTrail is no different and has an optional feature enabling CloudTrail logs to be delivered to CloudWatch. Okay, so we have always on, we have JSON format, we have event history, we have trails. Basically, if we need to go beyond 90 days of event history, and then we have deliverables, which basically ships the logs to CloudWatch. Awesome. As mentioned, CloudTrail helps capture and record actions taken. These actions could be interactions with any number of AWS services. For example, services like S3. So S3 is Amazon storage service. We call it S3 bucket service, I think. Amazon simple storage service used for object storage. So it is similar to the Azure blob storage, if you know about this. And IAM, AWS Identity and Access Management Services, can be used to secure access to your AWS environment with the creation of identities and the assigning of access permissions to those identities. So this is IAM. So on the Azure side, we have Active Directory. Now it is called Entra ID. We'll have actions taken within their service recorded. These recorded events can be very helpful when performing an investigation. Okay, clear. Intro to JQ. What is JQ? Earlier it was mentioned that CloudTrail logs were JSON formatted. When ingested in large volumes, this machine readable format can be tricky to extract meaning from, especially in the context of log analysis. The need then arises for something to help up transform and filter that JSON data into meaningful data we can understand and use to gain security insights. That's exactly what JQ is and does. Similar to command line tool like seed, AWK, grip, JQ is a lightweight and flexible command line processor that can be used on JSON. Awesome. How can it be used. Now let's take a look at how we use JQ to transform and filter JSON data. The wheres being the wheres, they stored their shopping list from the trip to the bookstore in JSON format. Let's take a look at that. Okay, so we have an array, as you can see, and then we have 1, 2, 3, 4, 5 items here. So we have Where's Valley, children book, page count is 20, then Charlotte's Web Crawler, Charlie and the 8-bit factory, the princess and the pcap. We saw this picture in the start of the task, the line, the glitch, and the wardrobe. Okay. So JQ takes two inputs, the filter you want to use, followed by the input file. We start our JQ filter with a dot, which just tells JQ we are accessing the current input. From here, we want to access the array of values stored in the JSON. Okay. So this is the input booklist.json. Okay, let's try that. But before I do anything, let me start the attack box. Okay, let it run. And in the meantime, I can do the same in my local. All right, so this should go to, for example, books.json, right? So let me paste the selection. Let's see, at books.json. Here we go. So we have JSON. So let's see if we have JQ installed. I think it's already there by default. Let's run it. JQ, I have it already. And then we'll start with the dot. I'm gonna, what happened? Invalid numeric literal L at line 3. What happened? Okay. Wait a moment. So this is what I have. If I just delete everything. All right, let's copy again. Here we go. I hope this is good now. Let's write it. Let's see if it still works. Yeah. Now, as you can see, the proper formatting is there with the quotation. And now our first command should run without any issue, as you can see. Awesome. Okay. So our tag box is ready now. Let's do the same in here. Book list.json. And let me press I to insert, edit, paste. I press escape, and then colon, W mean write and Q mean quit. Let's cat book list, and it is available here. Let's run the command again. JQ. Now we're gonna start with the book list.json. We are good to go. All right. Once we have accessed the array, we can grab elements from that array by going one step deeper. For example, we could run this JQ command, JQ and space, and then the pipe, then dot book underscore title. basically the name of the column itself, and then it will give us the actual data which is inside that column only. So let's try that. So we already have a command space pipe, and we are looking for book underscore title. Basically this is the same name as we have in this data. Here we go. Awesome. So we just have the data from that particular column only. That's a lot nicer to look at, isn't it? It gives you an idea of what JQ is and what it does. Of course, JQ can filter and transform JSON data in many additional ways. In our upcoming investigation, we will see the tool in action. Awesome. The peculiar case of care for where's dry funds. Okay. Now that we have refreshed our knowledge of AWS CloudTrail and JQ alongside McSkidy, let's investigate this peculiar case of care for where dry funds. The responsible wares for the care for where charity drive gave us the following info regarding this incident. We sent out a link on the 28th of November to everyone in our network that points to a flyer with the details of our charity. The details include the account number to receive donations. We received many donations the first day after sending out a link, but there were none from the second day on. I talked to the multiple people who claimed to have donated a respectable sum. One showed his transaction and I noticed the account number was wrong. I checked the link and it was still the same. I opened the link and the digital flyer was the same except for the account number. Ooh, okay. McSkidy recalls putting the digital flyer where valley bank account qr.png in an Amazon AWS S3 bucket named where valley care for wares. Let's assist McSkidy and start by finding out more about that link. Before that, let's first review the information that we currently have to start the investigation. So what happened here? 28th of November, everyone in the network, we sent a charity detail. So detail included our account number on which you can send us the money, right? So we received many donations first day after sending the link, but none were received on second day. Talked to multiple people who claimed to have donated a respectable sum. Somebody was taking the donation on our behalf. Something happened there. One showed his transaction and noticed the account number was wrong. Account number to where they sent the donations. Okay. We checked the link, everything was the same. Opened the link, everything was the same. So what happened? Except the account number. Account number was changed. So, okay, let's investigate and see what happened there. Before I do that, let's start the machine as well. The day after the link was sent out, several donations were received. Since the second day after sending the link, no more donations have been received. A donator has shown proof of his transaction. It was made 3 days after he received the link. The account number in the transaction was not correct. Okay. McSkidy put the digital file in the AWS S3 object named where valley bank account qr.png. So that means he put on the AWS S3 object storage, and somebody must have changed it, right? Under the bucket where valley care for wares, the link has not been altered. The link is not altered, but the account number is changed. How this could happen? Okay. Now that we have enough information, let's start the attached virtual machine in this task by clicking on the we've done so. So here we go. Do I need to start the tag box? We already did so. Just for demonstration purpose for the JQ only. Is there a split screen available? Yes. Do we need to start the VM? Yes, we already started it. Okay. Glitch did it. Okay, let's examine the CloudTrail logs related to the where valley care for where S3 bucket. For a quick example, a typical S3 log entry looks like this. Okay. So they already kind of gave us that maybe glitch did it. But from our previous task, we know that glitch is helping basically McSkidy to uncover what happened and who is attacking the infrastructure and the sites. Okay, so if they are saying that glitch triggered, that means somebody is trying hard to make sure that the blame will basically will be on glitch. Okay, so let's see what we have here. So this is the log entry. All right, we have the log entry. Do we need to copy or anything here? Okay, in the meantime, let's continue. But before we do that, there are a lot of attributes. I cannot explain everything. Let's see what they have highlighted here. It might be overwhelming to see the sheer amount of the information in one event. Yes, that's true. But there are some elements that we can focus on for our investigation. Field and description, user identity, details of the user account that acted on an object, event time, when did the action occur, event type, the type of the event occurred, e.g. AWS API call or AWS console sign in, AWS service event, event source, from what service was the event logged, event name, what specific action occurred, list objects and get bucket, that means which function we called, source IP address, from what IP did the action happened. So source is basically the source, the IP address of the IP address of the the attacker or the hacker who, or perpetrator or whatever. Apologies for not pronouncing it rightly. That will be the IP address of the attacker who is trying to perform some kind of action. Perpetrator. Okay. User agent. What user agent was used to perform the action, e.g. Firefox, AWS, and CLI. So user agent basically can be tricked. Either he was using the GUI from the Firefox or Chrome or whatnot, or he was using AWS CLI command line tools to do the action. Requested parameter, what parameter were involved in the action, like bucket name or whatnot. Awesome. By using the guide above, we can read the example logs entry as follows. I am user where value collector, list all objects, list objects event of the S3 bucket named AOC-cloudtrail-where value. Okay, the IP address is IP address from which this request originated. Okay, this is the IP address. The user agent indicates the request was made using AWS SDK tool for Go language. Okay. They are saying that we already have the logs on our system, so let's see if we have it. Click on terminal. Terminal is here. Instead of LAS, press LS. Yeah, we have where value logs. So let's go into it. We have created log JSON and RDS.logs as well. With the commands above, we initially changed our current directory to the directory McSkidy mentioned via the cd command. We listed the directory's contents using the ls command. As you can see, two files are inside it, but we will focus first on the CloudTrail_log.json for this investigation. Now let's start investigating the CloudTrail logs by executing the commands below. Okay. JQ-R records, then we are selecting dot event source is equal to s3.amazon and request parameter dot bucket name is this one, and then cloud. Okay, but before we do anything, let's see what we have in the CloudTrail basically. Oh, okay. So let's go with, for example, JQ, and let's try the same command that we used. Yeah, we have it in JSON format. Okay. I don't know about the minus or what they are. Okay, let's see the help section. what this OR is basically doing. Yeah, small OR is raw output, string without escaping and quotes. Okay. Okay. Let's try again. This was our request. Let's go with the minus OR. Let's see what happens here. Similar. Okay, this time we want to go with the records. Do we have records? Where is the record itself? It's a big file. Cannot scroll up. Okay, as I said, go with the records. So let's try the records. Yeah. Okay. And then we are selecting. Select one record. So this is the record. We are inside the record. So we are trying to go with the event source is equal to. So let's see what we have here. What is the actual structure here? Yeah, okay. So inside the record, we have the information. For example, this is the record starting point. And we have user entity as well. We have record event source. Okay. And request parameters. So request parameter is another one. Here I don't see anything here. It's a null. It's a null for this particular record. Let's see what we have above. We still have null here. So they are trying to go with the bucket here. All right, let's try. Maybe there are multiple records and some of them have this basically data here. Okay, let's go with select. We are selecting event source is equal to and then the s3.amazonaws.com. Okay, let's only do this. Are we missing something? Are we missing something? Yes, we did not close basically this select. What else? Yeah, okay. It will come after this quotation. Okay, so here we go. So request parameter have some information as you can see here. Awesome. So request parameter, we have configuration A or N for most of the things. So request parameters dot bucket name. We don't have this kind of information. Maybe we have this information, but in some other logs. All right, let's go with the other one. So as you can see, we need to use space and that we are looking for the records, which are basically request parameters dot bucket name is equal to okay, wait, we need to put the quotation mark here to close it and then put double quotation, and in between we need to put where valley dash care for wares. Okay, enter. So here we have everything that we were looking for. I can see a lot more information here. So where is it? So this is the requested parameters, and we have bucket name here, as you can see here. Awesome, awesome, awesome. We were able to do that. Let me put it in full mode, and let me minimize it to have more real estate so we can see the whole thing. Yeah, here we go. So after running this command, let's do a quick breakdown of the command we executed. So we have JQ -r filter cloud log.json. The R flag tells the JQ to output the results in a raw format instead of JSON. We were getting JSON records, right? Yeah. Note that the filter select section is enclosed with a single quote. The last part of the command accepts the input file, which is cloudtrail_log.json. Okay, dot records. Instruct JQ to parse the events in the records container elements. The record field is the top element in the JSON formatted CloudTrails. Okay, so this is for top element. So basically we are searching inside this particular element. Okay, and then we have the actual query. Uses the previous command output and filter it on the event source and request parameter bucket name keys. The value S3 Amazon.com is used to filter events related to the Amazon AWS S3 service, and the value where value dash care for where is used to filter events related to the target S3 bucket. Awesome. Let's continue. As you can see in the command output, we were able to trim down the results since all of the entries are from S3. However, it is still a bit overwhelming since all the fields are included in the output. Now let's refine the output by selecting the significant fields. Execute the following command below. Okay, let's see what we have here. Okay, so what we are doing here, we are piping it to just limit the output to these particular columns only. Okay, so instead of typing all of it, I will just copy it because we understand the command itself. So let me make it a little bit bigger. I don't know why it is not zoomed in. And one more time. I have those. I hope this is clear. Let's put our command here. All right, enter. Here we go. So we have 1, 2, 3, 4, 5 records, almost 5 records, and this is the information we have. So yeah, we can see glitch have done it. Glitch. This is NA, and then there is a glitch one as one. Okay, as per the logs, until now, somebody named glitch have done something. Right? What is the IP address? IP address is the same in all the requests. All right. As we can see, we have appended another pipe after our previous filter. Let's discuss it quickly. So this is the pipe. The pipe filter uses the previous command's output and format it to only include the defined keys such as .event type, event time, event name, and user identity.username. The defined keys are enclosed with the square bracket to process and create an array with the specified fields from each record. Note that string double forward slash and NA is included purely for formatting reasons. This means that if the defined key does not have a value, it will display NA instead. So for example, if .request parameter .bucket name does not have anything, it will just put NA here. Same is true for username as well. Awesome. As you can see in the results, we could focus on notable items, but our initial goal is to render the output in a table to make it easy to digest. Let's upgrade our command with additional parameters. Okay. So they have mentioned the parameters here, and then the record, then the select. But what is at TSV? Okay, let's execute first and then we'll understand what they are basically doing. All right, so here we go. Oh, it's awesome. It's in a table format. I like it. What if we don't just go with the column -t? What happens? It still give us the similar output, but it is not using tabs, right? So as you can see, it is formatted really good, perfectly, but in here the format is a little bit out, so we can pause column -t. Awesome, awesome, awesome. Now what is that at thingy? At TSV. Okay, we'll see. So this is our query. The new command prepends a column header row and is defined using the square bracket, since it is an array that corresponds to the selected fields. So these are the title of the columns for which we need to display the data for. Okay, so the number of columns should be similar to what we are selecting in our select filter or specific fields. Note that a comma is used before the select filter to combine with those of the select filter results in we previously used. So we are using this comma. Okay, then we have at TSV set each array element the output process from the filter as a line of tab separated values. So this is how it should be done at TSV. Then we have column. We are using just -t only. It takes the output of the JQ command, now results in tab separated values and beautifies its result by processing all tabs and align the columns. Okay, let's try this one as well, because this one we did not use. Okay, let me paste. Let's see what is different here. I don't see any different. Basically everything is similar. Yeah, I don't see any difference. So -t is the way to go. All right. Now with our crafted command, let's summarize S3 activities from a CloudTrail log. Now that we have crafted a JQ query that provides a well-refined output, let's look at results and observe the events based on the column. We can answer the following question to build our assumptions. How many logs entries we are related to the where valley care for where bucket? We have 5s, all right. 1, 2, 3, 4, 5, 5. Which user initiated the most of these logs entries? Glitch. This is the username, Glitch. Which action did the user perform based on the event name field? So event name is ListObjects. Put update, that means he updated. Then preferred request. And then we have ListObjects again. ListObjects. What is the timestamp of the log entries? Most of them happened on November 28th, and all of them almost 2-3 seconds after each other. What is the source IP related to these logs entries? So the source IP is 53.94.2201.69. Awesome. Okay. Looking at the results, 5 logged events seems related to the where valley care for where bucket. Almost all are related to the user glitch. Aside from listing the objects inside the bucket list object event, the most notable detail is that the user glitch uploaded the file. Yeah, they are putting the file. Yeah, this is the file we are putting. Usually we use a post to create a file and put to update the file, or patch to update the file as well. You can also use the put to create the file as well. The most notable detail is that the user glitch uploaded the file Where Valley bank account -qr.png on November 28. This seems to coincide with the information we received about no donation being made second day after the link was sent out. McSkidy is sure there was no user glitch in the system before. Oh, okay. There is no one in the city hall with that name either. The only person that McSkidy knows with that name is the hacker who keeps to himself. McSkidy suggests that we look into this anomalous user, deviating from what is standard and normal or expected. Okay, anomalous user. McSkidy fooled us. McSkidy wants to know what this anomalous user or anonymous user or suspicious user account has been used for, when it was created, and who created it. Enter the command below to see all the events related to the anomalous user. We can focus our analysis on the following question. What event types are included in these log entries? What is the timestamp of these log entries? Which IPs are included in these logs entries? What tools OS was using these log entries? Okay, so this is the log. So we are specifically searching for glitch now, and we are going for CloudTrail JSON log. Okay, so this time we are searching for just glitch user only, right? So let me clear it. Let's run it. What is going on here? What is expected here? Wait. Like that. What is going on, guys? Which is best? Okay, I removed the last one. Here we have. So all of them are glitch. So most of the events are coming for S3, Amazon, AWS, and some of them I'm going to health. Most of them are on SW. So glitch did the head bucket. Okay, list the objects, then put the object, list the object, console log in. Why he needs to sign in again? Get cost and usage. List enrollment statuses. Describe event aggregates. List get storage lens configuration. Less dashboard data internal, and he is trying to see something. What is going on here, right? Results show that the user glitch mostly targeted the S3 bucket. The notable event is the console login. Yes, console login is suspicious. We tell us the account was used to access the AWS management console using a browser. Using a browser. Okay, we are not getting the basically the agent or user agent right here. All right. All right, let's continue. We tell us that the account was used to access the AWS management console using a browser. We still need information about which tool and OS were used in the request. Let's view the user agent value related to these events using the following command. Okay, so what has changed here? We are still selecting username source. Yeah, we are using user agent now. Let's continue with this command. Okay. So what we are looking for exactly? So this is the user agent basically. S3 console 0 AWS. AWS Java SDK. Vendor Oracle. Here it is changed. It is back to Mozilla. That means he's using browser. And all of these are done with the Mozilla, and this is from the console basically. All right, there are two user agent values included in all logs entry related to the glitch user. So first one is SC console, yes, and second one is the Mozilla 5.0. This is the user agent string for the internal console using the AWS. It does not provide much information. Yes, this user agent string provides us with two pieces of interesting information. The anomalous account uses a Google Chrome browser within a Mac OS system. How? Yeah, this is Macintosh and this is Chrome basically. So the Mozilla is basically generic event. It doesn't mean that it is a Firefox Mozilla. They are using Chrome here. Awesome. An experienced attacker can forge these values, but we should not dismiss this information. It can be valuable when comparing different log entries for the same user. We will park the current information for now. Let's gather more information to connect the dots. The next interesting event to look for is who created this anomalous user account. We will filter for all IAM related events, and this can be done by using the select filter.eventSource is equal to im.aws amazonaws.com. Let's execute the command below and try to answer the following questions. What event name are included in the log entry? What user executed these events? And what is this user's IP address? Okay. So what has changed here? We have select. Now for the event source, we are going for the im.amazonaws.com. Rest of the information is same. We removed the user agent part here. Okay, let's copy. And go back here. All right. So the username is McSkidy. So all of users are McSkidy and all of the IP addresses are the same. Oh, create user is done by McSkidy. Oh, so it is McSkidy's account. Based on the result, there are many list policies events. Yeah, there is a many list policies event. Events. By ignoring these events, it seems that the most significant IAM activities about the user McSkidy invoking the create user. Yeah, that is correct. Action and consequently invoking the attach user policy action. The source IP where the requests were made is the 53.94.201.69. Remember that it is the same IP the anomalous user glitch used. Yeah, that is correct. Let's have a more detailed look at the event related to the create user action by executing the command below. So we are just going for the create user event now. Okay, so they already prepared the command, so we will just copy and paste. Otherwise we needed to do it by ourselves. Okay, let's see what we have here. So the user date is IAM, and this is principal ID. This is user McSkidy. This is created on this particular date. Session context. Okay, then we have created user. same IP address basically. And this is a Macintosh and Chrome. User requested parameter is glitch. So basically McSkidy is creating a user glitch, as you can see here, and it is a API, and we are using management, and TLS is 1.3. okay. Based on the request parameter of the output, it can be seen that it was the user McSkidy who created the anomalous account. Now we need to know what permissions the anomalous user has. It could be devastating if it has access to our whole environment. We need to filter for the attached user policy event to uncover the permission set for newly created user. This event applies access policies to users, defining the extent of access to the account. Let's filter for specific event by executing the command below. Okay, so what we have changed here. So event source is the same, and we created and event name is attached policy. So this is just one event. We just want to see more information about that. There is no forwarding or anything. That means we need to see the result in the JSON format. Okay, here we go. McSkidy. So policy is administrator access. So we gave basically everything to the glitch. He can do anything. That means he can create, delete, or update the files on the S3 bucket. Policy is administrator access. He can do anything. McSkidy is baffled by these results. She knows that she did not create the anomalous user and did not assign the privileged access. She also does not recognize the IP address involved in the events and does not use a Mac OS. She only uses a Windows machine. All this information is different to the typical IP address and machine used by McSkidy. So she wants to prove her innocence and asks to continue the investigation. Logs don't lie. Sometimes it does lie if they tamper the logs, but usually real-time logs don't lie. McSkidy suggests looking closely at the IP address and operating system related to all these anomalous events. Let's use the following command below to continue with the investigation. Okay. So now we are searching for source IP address, and yeah, this time we are forwarding as well. Maybe we will have a lot of logs. Copy. Let me put the clear first. Let me run it here. Oh wow. Yeah, this is interesting. Mayor Malware. So the IP address is the same. So we can see that the user who tried first is Mayor Malware, and then the same IP address then was used with the glitch username, and then the glitch user created the object, and then the Mayor Malware basically logged in. He did logged in with the McSkidy and glitch again, and then McSkidy list the policies, get the policies, list the policies, and then create a login profile, attach user policy. We already see that what are the parameters to that, and then list and create user is created. Then the glitch itself did something here, as you can see, and then the ConsoleLogin events are from the Mayor Malware. So Mayor Malware is the new entry here. I think Mayor Malware basically started the whole thing here. Based on the command output, the three user accounts, McSkidy, glitch, and Mayor Malware, were accessed from the same IP address. This is interesting. The next step is to check each user and see if they always work from that IP. Let's focus on each user and see if they always work from that IP. Enter the command below and replace the placeholder with the username. So this is the username. All right. So let's go with McSkidy first. The spellings are right. So all MCS kiddie, all small. Here we go. You can see that McSkidy usually come from 53. But this is a different IP address as well, and instead of Macintosh we have Windows here, so there is something going on here, right? All right, let's go with the other one, glitch. What are the spelling? So it is GLITCH. GLITCH. Let's see now. So we have 53, 53, 53, 94. Yeah, he always uses the same IP address. Okay. What about the Mayor _malware? So let's go with Mayor _malware. Get up on wrong spellings. MA. Okay, we are expecting O here. Mayor _malware. Okay, he should not be there. So I'm pressing Control and then the arrow to make it quickly navigate. Malware. Okay, so here we go. It is also using the same IP address as glitch was using, but the only difference is the McSkidy is using different IP addresses. Okay, this is clear. All right, let's focus on. Yeah, we've done so already. And while getting the information for each user, we can focus our investigation on the following question: which IP does each user typically use to log in into AWS? Which OS and browser does each user usually use? Are there any similarities or explicit difference between the IP address and operating system used? Yes, we saw that for McSkidy only. Based upon the result, we have proven that the McSkidy used a different IP address before the unusual authentication was discovered. Moreover, all evidence seems to point towards another user after correlating the IP address and the user agent used by each user. Who do you think it could be? McSkidy has processed all the investigation results and summarized them below. The instance starts with an anomalous login with the user account McSkidy from this particular IP address, which is not the IP address of the McSkidy. Shortly after the login, an anomalous user account glitch was created. Then the glitch user account was assigned administrator privileges. The glitch user account then accessed the S3 bucket named Ware Valley -care for wares and replaced the Ware Valley bank account QRPNG file with the new one. The IP address and the user agent used to log in into the glitch and McSkidy and malware account were the same. The user agent string and the source IP of the recurrent login by the user account McSkidy are different. That is correct. We have observed all of this. So definite evidence. McSkidy suggests gathering stronger proof that that person was behind this incident. Luckily, Ware Valley Bank cooperated with us and provided their database logs from their Amazon Relational Database Service (RDS). Okay. They also mentioned that these are captured through their CloudWatch, which differs from the CloudTrail logs as they are not stored in the JSON format. For now, let's look at the bank transactions stored in the Ware Valley logs RDS.log file. Since the log entries are different from the logs we previously investigated, the McSkidy provided some guidance on how to analyze them. According to her, we can use the following command to show all the bank transactions. Grep is a Unix command line, a utility used for searching strings within a file. Okay. So, so grep insert, we are looking for a word insert in rds.log file. So let's run this since we are in this same folder. So if I say clear, as you can see, we have rds logs already. So let's see that. Wow, we can see a lot of these are from the Mayor Malware, basically. Insert. We have account number, we have account owner, and we have the amount itself. This is account number, owner, and then the amount itself. And all of this is coming. Oh, so instead of going to the Care for Ware fund, it is going to the malware account, which is also this information. Oh, so we can see that the amount is received by the Mayor Malware. So this is proved he stole our money. From the command above, McSkidy explained that all insert queries from the RDS log pertain to who received the donations made by the townspeople. Given this, we can see in the output that the two recipients of all donations made within the November 28, 2024 is going to the Mayor Malware. As shown above, the Care for Ware fund received all donations until it changed into a different account at a specific time. The log also reveals who received the donations afterwards. Given the account owner's name with all these findings, McSkidy confirmed the assumption made during the investigation of the S3 bucket, since the sudden change in bank detail was reflected in the database logs. The timeline of the events collected by the McSkidy explains the connection of actions connected by the culprit. So we have timestamp is 1522:18 second CloudWatch RDS logs, rds.logs, logs donation received by the Care for Ware fund, and then on 39 second the CloudTrail logs, bank details update on the S3 bucket, that means the QR code was updated, and then on the 23rd minute CloudWatch RDS logs, rds.logs, the first donation received by the Mayor Malware. Okay, what is the other activity made by the user glitch inside from the ListObject action? ListObject action. Right. So we already have a query for that. So let's copy the query. So event name is basically So this is the query we are looking for, hopefully. List objection. What is the other activity made by a user glitch aside from list object action? So we are looking for a user, right? So this is not the query. This is the query that we need. Aside from, okay. So we are looking for glitch. Let's change the username to glitch. We have run this command already, but I didn't want it to go through the command history. Okay, so we are using put objects ConsoleLogin. Yeah, put object. Maybe this is what we are looking for. Aside from, yeah, put object. What is source IP related to the S3 bucket activity of the user glitch? Source IP is S3. So here is the source IP address. Based on the event source field, what AWS service generated the console login event? Based on the event source field, what AWS service generates the source console log event? So it is login or IAM. Where is the IAM? This is how this is called sign in. I think, yeah, sign in.aws console login. All right, we are good. We remember everything. When did the anomalous user trigger the console login event? When? So when is this one? I hope this is the file they are looking for. Yeah, okay. What was the name of the user that was created by McSkidy user? Glitch, of course. Glitch. Yeah. What type of access was assigned to the anomalous user? So it was administrator access, right? So we see that, and basically here. Okay. If we run this one, so inside attach policy, basically, so we want to go with the attach policy, right? Attach user policy. So this is the event we are looking for. Yeah, here we go. We already have this. So this is administrator access, right? So this is what we are looking for, hopefully. Long string. Yeah, awesome. Which IP does malware typically use to log into the AWS service? He is using the same IP address for everything. Do we have IP address here? Yeah, here we go. We know this because of we reviewed these logs, right? So that's why we know all of this. What is the McSkidy actual IP address? Okay, so McSkidy's actual IP address was different. It was 32 something. So all right, so we need to run a command where we were getting the information per user. So here we can mention the McSkidy and we will get to know the IP address. McSkidy. So here's the IP address, 31 2 10 15 and 79. All right, let's put this here. Awesome. What is the bank account number owned by Mayor Malware? Sure. So it was in the RDS, right? So we were looking for RDS logs at the very end. So we were looking for this one. Copy. There we go. So the account number is this one. Hopefully. Yes, awesome. Want to learn more about log analysis and how to interpret logs from different sources? Check out the log universe. Sure, let's see what we have in this room. So it will take 60 minutes to do all of this. Awesome. So thank you guys for joining me on this journey. We have completed our task 13, day 7. I know I'm very late, but I told you we will be completing it before 31st of December. So we will push and try to complete everything before 31st of December. Thank you guys for joining me, and I will see you in the next video. But before that, please subscribe and like the video, and if you have any comments, please mention in the down below, and I will see you in the next video. Bye.